guys. Today we guys will discuss about the protein classification. In my previous video, I have discussed protein in very detail with the structure and the basic points and the MCQs. So in this one video, I will be going to discuss about the classification of the proteins. So first of all, let me tell you that proteins are classified on two bases. Classified on two bases. Okay. So the first one is on size and shape, and the second one classification is on the basis of composition, structure, and physical properties and solubility. Physical properties and solubility. Okay, so first we guys are going to discuss about the classification on the basis of size and shape. Okay, so basically on the basis of size and shape, it is divided on the subparts. So first part we are going to discuss. Okay, so as you guys can see that this is basically the fibrous protein structure, which is having a alpha helix structure. It is having a alpha helical structure, and they are made up of long parallel polypeptide, long parallel polypeptide chain along single axis. You guys can see over here. You guys can take a look over here that they are made of long parallel sides along single axis. Then it is soluble in water, and it is the structural element of muscle tissue myofibrils. Okay, the examples of the fibrous proteins are keratin, collagen, hairs, and nails. These are found in our hairs and our nails, keratin and collagen, and it is spirally in the structure. You guys can see over here in this one diagram, and it is having hydrogen sulfide bonding. It is also known as secondary structural protein. You guys can see over here that they are composed right like as I discussed in the previous video, 1 1 and 2 2. Okay, G. So next we are having a globular protein. Okay, so globular proteins have polypeptide chain, tightly compacted structure. Okay, and it is having single tertiary structure, means that it has quaternary structure. Single tertiary means that it has quaternary structure. The examples of the globular proteins are myoglobin, hemoglobin, and many more. So let me just show you a picture of globular protein. Okay, so basically it is an example of the myoglobin of the globular protein, which is a globular protein. So you guys can see over here that it is having a polypeptide chain polypeptide chain between over here. It is having a quaternary structure, and as you guys can see over here that it is having a spirally structure. So yes, this is the difference between these two. Okay, so you guys can take a look over here that the difference between the globular and the fibrous protein. I have some extra points. So if we talk about the shape, so the shape of the globular is roughly circular, as you guys can see this over here. Then if we talk about the fibrous, so fibrous is having long straight. You guys can see that in the previous video, in the previous picture, that it has, I'm really sorry, that it has this one structure. Then if we talk about the amino acid sequence, what it's having, so it is having irregular irregular and wide range of radical groups, and it is having repetitive with a limited range of radical groups. Then if we talk about the function, so globular is having physiological and functional, and fibrous having a structural function. And the example of the globular is hemoglobin enzyme, insulin, and immunoglobulin or myoglobin. And fibrous examples are collagen, keratin, myosin, actin, and fibrin. And if we talk about the solubility, so globular is soluble in water as our blood is, and in fibrous it is insoluble in water. Okay, G. So this is all for today. I will be discussing about my next part about the composition and the solubility physical properties in my next video. So stay tuned for that.